Welcome back to our channel. Today's video is sponsored by me. Follow me on Instagram. It says my handle right there. Tatiana Dazinski.
I would never watch this live.
Now enjoy the lesson. Pay attention.
The lesson, I'm not watching the video. You guys have one out to see
Alright, so we're going to talk about rational functions. We're going to talk about graphing rational functions. So today we're going to go through the second part. The second part is to talk about more extensive and other stuff. So,
And Brandon, you have a 2%.
okay, so anyway, so we can graph rational functions. So we talked about yesterday. Okay, graph rational functions. So the first step we talked about already. We have to factor the numerator and denominator. The second step is find the location of the whole, if there's any. Find location. And we talked about the whole has a different name. It's called removable discontinuity. So find the location of the whole. So now you're gonna set the cancel factor equal to 0. Solve it and plug in into new equation. New equation after you cancel, if there's anything cancel. Okay? So we talked about that second step. We did this yesterday. Yes?
Let's just factor the factor equal to 0.
Set a cancel factor equal to 0. Cancel. Okay? So Brendan, Joseph, why don't you pay attention? Okay, the third step is that we're talking about there's a reason where we find the whole first before we find the vertical asymptote. A lot of you guys get confused. Sometimes you have to find, all the time you have to find the whole first. If the whole exists, sometimes it may not have vertical asymptote. So that's why you guys have to understand. So this step is very the procedure of kind of graphing rational function. It has to go through each steps. Okay. So the third step is what? The third step is find the vertical asymptote. Is set the new denominator, set the new equation, right? New equation denominator. So the new denominator equal to 0. If you set the new denominator equal to 0 and solve it, you're gonna find vertical asymptote. Okay? So that's my vertical asymptote. So we're gonna call it VA. The fourth step is find the horizontal asymptote. Okay, find the horizontal asymptote is the limit x approach to infinity of f of x is equal to some type of number. Sometimes we have that some number. And limit x approach to infinity of f of x equal to L. We're going to talk about this two things. So these two things we're going to talk about more extensive. So horizontal asymptote is basically you compare the highest degree. So this in calculus, this definition in calculus also in pre-calc. So we want to address that. What does limit x approaching infinity mean? X approaching to negative infinity means? Okay, so, but basically in algebra 2 way, which we're going to talk about, is compare the highest degree. Highest. Do you guys know what degree is?
Yes. No.
The angle.
No.
Oh no.
That's an embarrassment. Degree is the exponents, right?
Yeah.
The exponent of the function. So we are comparing the highest degree of the exponent.
Does that say compare?
Yeah, compare.
Compare.
Okay, so what we're trying to tell you is there was two types of asymptote. There was actually three types in this case. There's first type is a vertical asymptote. Vertical asymptote is something you cannot touch.
Oh.
It's like
It's because it's the super badass, right?
yeah, it's the baddest of the bad. Like you cannot touch them. You just cannot touch them. Just imagine like Jeffrey, and Jeffrey will never have a chance with Beyonce. It's sort of like that.
Ignore. No, say ignore. Just see hammer a force field. Jeffrey never has a chance to ignore.
Who's Nora?
Yo, why you gotta put me on
Why you put them on?
This one girl is trying to get
No, I'm
I
not
thought you were having a girlfriend.
I'm not trying to get at
He doesn't have a
Noah.
girlfriend.
Huh?
I don't have a
You
girlfriend.
said girlfriend?
Yeah, I thought he has a girlfriend.
Yeah, me too.
No.
He has a
Who would that be?
That's
Who would that be?
It's complicated,
Yeah, he has a
It's
complicated
not complicated, you don't
significant
have a
other.
girlfriend, point blank period.
All right. Anyway, so
He has a complicated significant other.
so you compare the highest degree. So think about vertical asymptote. Shh. Think about its vertical asymptote, something that you can never be there. You can never be as good as Michael Jordan.
Michael B. Jordan.
So you're trying to limit myself.
Yeah, Andres.
So those are the things that vertical asymptote is never gonna touch them. But horizontal asymptotes is slightly different. Okay? Sometimes they can touch the horizontal asymptote. We're gonna give you a couple cases that give you to look at it. But now, how do we compare highest degree? Yesterday we talked about Bill Gates and we borrowed $2 from Bill Gates. So what is significant? So we're gonna talk about following three equations. So there was three possibilities here. The first possibility is this. If the top, the numerator, so we're gonna say top degree is higher, that means there is no horizontal asymptote. Okay, the second thing is, if the bottom degree is higher, the bottom degree is higher, that means y equal to 0. Gabby, put your computer away.
Sir, wasn't my top, you mean top to be like that, right?
We're gonna talk about it. Just don't worry about the question right now. We're gonna show you example because right now it looks like Jaden. Okay, so now we're gonna compare if they are the same degree, top and bottom, for top and bottom, for top and bottom. Right, it's top and bottom, then you look at the coefficient, Or you divide the coefficient, the coefficient, leading coefficient. So now we're gonna talk about what are those three cases. So a lot of you guys are saying, what is he talking about? Well, it can be a pattern in this case. So first case we're going to talk about is if you have f of x, and let's say 3x squared minus 2x plus 1 over negative 2x squared plus 2x plus 4. The second case we're going to talk about is f of x And they are different, okay? So 3x squared to the third plus 2x minus 4x squared plus 2x minus 1. And the third case is f of x is equal to 3x to the second plus 3x over 4x to the third plus 2x minus 1. So why do we only compare the highest degree? So we're going to talk about that.
Wait, what's UA?
Huh?
UA?
Here?
Oh, vertical asymptote?
Yeah, vertical asymptote.
Sir, when it says same degree means when both of them are the same, right?
Yeah, so we're going to talk about like when they're the same. So let me know if you have any questions so far about writing or whatever. Degree means the exponents. Okay? Yes. Yeah, L?
Yeah.
L is just a number.
Oh, L is just a number?
Yeah, L is just some type of number.
Oh.
So what's that
Okay.
part mean for the same, look at the coefficient?
Look at the coefficient, divide the leading coefficients. So we're going to talk about that. We're going to show you how does it work. If you look at the first case, you think about a 1 and 4, right? Remember, what is horizontal asymptote? It just told you to plug in infinite. Plug in infinite. And plug in infinity on the x, because x approach infinite. So x go to infinite, what will happen? So let's talk about, if you have, just imagine that if you have this, right? And we're going to talk about why is a lot of things are negligible. So we're going to say infinity squared minus 2 infinite plus 1 over -2 infinite squared plus 2 infinite plus 4. Now this is not mathematically correct, but it's a good idea to show you what happened. So let's just compare infinity and 1. Does the infinity matter?
No.
No, sorry, does 1 matter?
No.
Because infinity at 1, so you give Bill Gates, here's Bill Gates, I'll give you $1. And the Bill Gates is like, okay, it doesn't really matter, it doesn't really add to his asset, right? So that 1 and $4 doesn't make any difference. So we don't even look at the constant. The constant does not matter. That's what we say compare the highest degrees. So now we say, hey, imagine this. This is infinity squared. Infinity squared is kind of hard to understand. Which one's bigger, infinity squared and infinity? Which one's bigger?
Infinity squared.
Oh, they're the same. They're the same.
Beyond infinity.
Well, infinity squared is still going to be. Idea they can be described the same. Or the infinity squared. Let's think about if you have a $10. If a $10 square is going to be what? 100, right? You rather have $10. You rather have $100. Right. So let's say $100. $100 square is what?
10,000.
10,000. So 10,000 and $100, which one you want to have? 10,000. So if you realize the number gets bigger, the smaller number becomes insignificant. Just think about 1,000. 1,000 square is what?
A million.
1 million?
Yeah.
So
Yeah.
it's, if you have $1 million and $1,000 becomes insignificant. Do you see what I'm saying? So you're not compared to this. You compare the highest degree. That's what we talk about. You compare with the highest degree. You don't care about what happened at the lowest. So this one is all of the comparison because infinity squared is going to be way over infinity. Now, you basically look at this two things. You look at a 3x squared over -2x squared, right?
Not infinity, x.
No, we just think about they are going to be infinity. But infinity squared, they would cancel out. But just think about if you just look at the degrees now. If you look at x squared, do you understand why this is not significant?
Yeah.
Or we call it negligible.
Yeah.
It's not important. So now we just compare the highest degree. Compare the highest degree. This is x to the second. So there's 3 Bill Gates square, and there's -2 Bill Gates square. So Bill Gates square can go away. So just think about this one can cancel out. So your answer is y is equal to -3 over 2. So that's your horizontal asymptote. So you look at the highest degree. If they have the same degree, that's easy. Same degree, just look at the coefficient. You divide the coefficient, that's your horizontal asymptote. Now let's look at the second case. We know 2x and 2x minus 1 is negligible. These are not important anymore. The only thing we compare is what? 3x to the cube and 4x squared, right? But x squared, I can cancel out. That's one that's going to be 3x over 4, right? So here's the thing. If I go to infinite, 3 times infinity over 4, what do you think the number is going to be?
Over.
It's going to be infinite. Okay? So why that's hard to understand. So that you think about this is a 3 times infinite divided by 4. Well, 3 times infinite divided by 4 is still going to be infinity. It's going to be quite big. So in this case, the top part is degree is higher. So the top degree is higher. There is no horizontal asymptote. The reason why no horizontal, do you understand the horizontal asymptote? Horizontal asymptote is like a plateau. It's going to go into like this. Imagine this. If I says you can take a retake infinite amount of time, okay? And every time you retake, I'm going to average both scores. So that's just, for example, you score a 0 on the first test. And then you take a retake, you say, I study everything, I got 100. So it'll be 100 plus 0 divided by 2 is what?
50.
Okay, 50. So then you take a 50, you say, Mr. Ye, I want to take the exam again. I want to get higher score. So the second time you got 100 again. So 100 plus 50 divided by 2 is what? 75, right. So now I'm going to do it again. 75 plus 100 divided by 2, that's going to be 87.5. And then you do it again. But do you see that increase getting slower now?
Yes.
So eventually you're going to go to like 94 and maybe 93, 94 and maybe 97 and maybe 98.5 and maybe 99.25 and maybe, but it's never going to get to 100. To be exact, the score is, you can round it up to get 100, but you never get to 100 because there is something called plateau. Now plateau is an asymptote. That plateau, the idea of an asymptote is plateau into a number. In terms of calculus 2, that's called converge. It's converge into a number that can be defined. And we're going to see it on the graph also. So we're going to see in this case, this one is going to infinite. So the number never converge. The number just keep on going to infinite. It never converge into a plateau. In this case, it's plateau into -3/2. We're going to show you in terms of graphing. Now the next case here, we compare the highest degree. What is highest degree? 3x squared over 4x cubed, right? Can that be simplified? 3 over 4x, right? So there's two ideas you need to understand. If you got infinite over a number, it's still going to go to infinite. Any number, okay? But if you have a number, any type of number over infinite, that is always going to 0. And you're like, what? Okay, so let's say it doesn't make sense.
Did you just pull a marker then?
Okay, so those two cases, right? Then you say, okay, what are those two cases? Just for example, I want to go to somebody's house. Let's say, which house do I want to go to? Let's say I want to go to Ken's house to purchase something. So I'm gonna go to Ken's house, and Ken's house about 50,000 miles away. Okay, so far away that it's hard time to get there, right? And then I said, no, oh well, Ken's house is kind of far, it's 50,000 miles. Now let's go to, let's say Bendy. Bendy's house is infinite long. Infinite, okay? The idea of infinite versus 50,000. So I can do this. I can maybe build a vehicle and travel like 50,000 miles per hour, okay? So then I can go into Ken's house in 1 hour. However, if I were to drive the same vehicle to try to go to Bendy's house, I still never get there because the distance is getting longer and longer and longer because there is no end inside. So if you compare like this, so let's do easier comparison. If you have any number, any concrete number that is on the top, and any number on the denominator, just say if you compare $1 versus $10, then it's going to go with 1 over 10, right? Now, the number's getting bigger, so it's not $10 anymore. Let's compare 1 to 100. 1 over 100 is what? 0.001. 1 over 1,000, 0.00001. 1 over a million, 0.0000001. And then eventually this part is going to go to what? 0. But it doesn't matter how big the number is though. If I start with like 50,000 on the top, if we go to infinite here on the bottom, the number is still going to go to 0. Do you understand now? So the idea is, doesn't matter what number, long as you have a set number. Could be quadrillion, billions, or whatever. But the bottom is infinite, then it's still going to go to 0. The top part, if it's infinite, on the bottom is some type of number. If when you divide it out, so let's say 100 divided by 10, that's still 10. 1,000 divided by 10, that's 100. A million divided by 10 is what? It's going to keep on going. So therefore, this is infinite, this is 0. So now what happened? If you have 3 over 4 times infinite, what will happen?
0.
It's going to 0, right? So that's how they comparison. Now let's look at it, see if we imagine the idea. The top part degree is larger, then it's not convergent. Seriously? Just find it and turn it off.
Sir,
We don't throw it out, you can throw it out, I don't care. Okay, yes.
so will we get problems like that, or will we get problems with of like for infinity?
Give me a second. Let me show you how it is first. Your problem is going to give you like this. Find the horizontal asymptote. You're going to say, okay, the answer is y equal to negative 3 over 2. Or there's no horizontal asymptote. Or y equal to 0.
We're gonna graph.
Okay? So we're going to show you the graph. So we're going to graph each thing and show you what actually happened. What actually happened here is here. Sarah, can you move that camera to the center? Okay, so what's the first graph? What is the first graph? Y equal to what? What's the first graph? 3x squared, right? Can somebody read it to me? Minus 2x
Plus 1
plus 1
over
over
negative 2x plus 2x.
over what?
Negative 2x squared
Negative 2x squared
plus 2x plus 4
plus 2x.
plus 4.
So we got this ugly graph, right? Stop acting like.
It was an accident. No.
Okay, so if you look at here, let's say y is equal to what? Negative 3 over 2, we said. Okay, do you see this dotted
It
line
says
here?
watching a stream.
Hi, Eli. Eli, how are you?
So let's look at here. Now let's look at, remember, we don't say what happened in the middle. The middle doesn't matter. The middle they can touch and they can go across. Horizontal asymptote can cross in the middle region, just not an end region. So when you go to look at a region, you say, okay, you look at this line, are they touching? It looks like they are, right? So we're gonna go to somewhere to see if they are for sure touching. So let's go to, let's say, that's what I meant by plateauing. Plateauing. So let's go to like 200. They seem like the lines are touching each other,
Yeah. Well, follow me on
right? But we're gonna go here.
I'll follow you back.
We're gonna zoom in. And we're gonna zoom in more. Are they still touching? Yeah, they are. They're still touching.
Mm-hmm.
Did I hear
It's still touching.
Yeah. You're not touching. Oh my god.
Oh,
So-
it's the same thing with the other thing.
We don't care about what happened is they're not touching that horizontal asymptote, but we don't care about what happened in the middle though. Sometimes in the middle they do go across. Okay, we're gonna show you an example of how do they go across. But in this part, it's go to infinite. So far on the right, so far on the left. They're not touching, they just keep on going. Eventually it's gonna plateau into a number. Eventually it's gonna plateau into a number. So it's gonna get into that number that is barely there, but it's not there. Okay, so let's change some graph and see what happens. Let's change that, maybe something that can change the graph a little bit. So let's change this to maybe negative. See here, you see this one? I just changed this number to negative, but this point did intersect the horizontal asymptote. Horizontal asymptote is not untouchable. They actually touchable. They don't care about what happened in the middle region. They don't care about what happened in this region. They only care about far left and far right. Both ends, even on the other end. If you see the other end, right, you see the other end, it's still a plateau. It's still a plateau. Sometimes they can go into a different way, but it's still going to plateau into a number that is never going to get there. So the idea of that is very important, that you can plateau into something. In math, this is a very, very big idea. It's called conversion. It's converging into something. Okay? So this is the first part. What is the second equation? Can somebody read the second equation to me?
Yeah.
Got you.
3x.
3x cubed
3x to the cube
Uh-huh.
You got 5 viewers,
Plus
sir.
2x
plus 2x.
over
Both go to the 10.
4x squared plus 2x minus 1.
Plus 2x minus 1. Okay. So we're going to see this graph, great graph here. We say there's no horizontal asymptote. See if that's true. We're going to get rid of this graph. And then we're going to go in here. There was no horizontal asymptote. Do you see there is no plateau into some number? The both end here, you see this end here? It's going to infinite. And this part is going to go to infinite. Okay? It's going to go negative infinity. But because it does plateau into something, because the number just keep on increasing, it never did stop. It never did stop. Okay? So now, let's go to the last one. What's the last one?
3x squared
3x squared
plus 3x
plus what?
3x.
over 4x
Over what?
4x cubed
4x cubed.
plus 2x.
4x to the cube. Plus 2 thirds.
No, 2x
2x
minus 1.
minus 1. Okay, so you see here, it's plateau into what? Y equal to 0. You see that? It's plateau into here. And it's only happened at the end. It's only happened on left hand and right hand. But in the center, they actually intersect twice. So horizontal asymptote is, it's intersectable, if that makes sense. It's actually, you can touch them. Because the definition of horizontal asymptote is telling you what happened when they reach infinity. When they reach infinity, it's going to come into converge into one number or not. So you look at the degree of the highest degrees. You don't look at the lowest degree because they are insignificant. The constants are insignificant. The second lowest degree is 9.4.
So those don't affect this?
It doesn't affect at all. It will affect how they change. So now, can you stop acting stuff?
I'm not acting stuff. Mr. Eli's in the chat, I think.
Who's Eli?
The one that's over there.
Huh?
The one that's super there. He's not
Oh,
here.
Eliza?
The one that's not here.
I call him Eli because they're on nickname basis.
That's cool.
Okay, so
I said
Curse?
break.
okay, so we also gonna add one more step here. So again, let's recap everything. Today's homework is very easy. You just have to determine what is. We just have to determine what the horizontal asymptote is by looking at the highest degree. If they are the same degrees, it's gonna be number divided by each other. If the top part's degree is higher it's gonna reach infinite, because infinite over a number is gonna be infinite. The graph's gonna keep on going up. It's never converge.
Wait, so we don't need to graph it, or do we also?
You don't need a graph, because tomorrow I'm gonna put everything together, graph. But we're gonna talk about last step. Hold on, don't. So this part, hopefully you have to copy it down.
What?
So we're gonna talk about fifth step. The fifth step here, the fifth step is very important, is looking for slant asymptote. If no horizontal asymptote, if no horizontal asymptote, you have to check for slant asymptote. And using something called long division. Okay, that's what we learned long division for. Because long division is going to help you find the slant asymptote.
Can you
Huh? No, not synthetic.